So welcome back guys. In this lecture video we will going to understand and discuss the IP address mathematics. So every IP address is associated with a mask value and a mask value is a value between 0 and 32. So we discussed in the last slide that the IP address size is 32 bits, right? And every IP address is associated with a mask value. And the value of this mask value is nothing but it is any value between 0 to 32 for IPv4 addresses. Just to let you know that for IPv6 addresses the mask value is 0 to 128 because the size of IPv6 addresses is 128 bits, right? So every IP address is associated with a mask value which is the value between 0 and 32. Mask is used to form subnetworks, right? So when we say that we have a subnet, we should know the following three information regarding subnet. That is the network ID of a subnet, what is the broadcast address of the subnet, and what is the maximum number of machines which could be present in the subnet. Yeah, that is true that you cannot place as many machines as you want in a given subnet. There is maximum limit on the number of machines which you can connect to a given subnet. So given a subnet, that is the IP address and the mask, we should be able to calculate these three information regarding a subnet. That is the network ID of a subnet, the broadcast address of the subnet, and the maximum number of machines which can be present in that subnet. So let us see how we can calculate each of these information for a given subnet. Let us take an example of machine B. So in our topology you can see that we have a machine B which has been assigned an IP address 11.1.1.3/24. So 24 is the mask value. So we will use the machine B's IP address and mask value to compute these three pieces of information for a given subnet. So I am showing you here the results. The network ID of this entire subnet is 11.1.1.0/24. This is the network ID. And the broadcast address of this subnet is 11.1.1.255. And the maximum number of machines that can be present in that subnet is 254. Why 254? We will discuss that why we have applied this formula to get the maximum number of machines which can be connected or can be placed in this subnet. So let us discuss how each of these pieces of information is calculated from an IP address and a mask value assigned to one of the machines present in the subnet. In this example, we are taking the machine B as a test machine. So the user input to calculate all these pieces of information is the IP address and the mask value of one of the machines present in the subnet. In our example, we have taken the IP address and the mask value that is assigned to a machine B. So let us see how to calculate the subnet ID from IP address and mask value of machine B, right? So in order to calculate a subnet ID, follow the following steps. So represent the IP address in binary format. So this is 11.1.1.3. So this is the binary representation of IP address 11.1.1.3. Now, next is to create a binary number B from mask such that first 24 bits are all ones and the remaining bits are 0. So remember the mask value that is assigned to the machine B is 24. So prepare a binary number such that first 24 bits are ones and the next 8 bits are 0. Remember, the length of the mask value is 32 bits. So in step 2, we have obtained a number in which first 24 bits are all ones and the next 8 bits are all 0. So to obtain the subnet ID, you just need to perform the logical AND operation of the binary number which you have calculated in step 2 with the IP address which you have calculated in step 1. So if you perform the binary AND operation between the results obtained from step 1 and step 2, the final result that you obtain is the following binary representation of IP address. So this IP address is 11.1.1.0 and this is what is the subnet ID. So this is fairly very simple. Follow the step 1, 2 and 3 to calculate the subnet ID. Now you can convert the result that you have obtained in step 3 into the decimal format, and after converting this binary number into decimal format you get 11.1.1.0/24, which is actually the network ID. Right? So this is fairly simple.